What if I told you that the leftover food you threw into the dustbin is the same waste Sweden uses to run its buses all year long?
And it means we're making a double mistake. First, by wasting all that food, and second, by literally throwing away the powerful fuel that's hidden right inside it. But that raises a pretty huge question, right? How on earth can simple food scraps generate enough energy to move a multi-ton city bus? What's the actual science that makes something like this even possible? Well, when you start digging into the science, you find the most surprising part of this whole thing. This incredible process, it all hinges on these tiny, invisible workers that you can't even see with the naked eye. So, let's get right to it. What kind of energy is actually locked inside our food waste that's powerful enough to run a multi-ton city bus? The secret ingredient, the real energy hiding in that waste, is methane gas. And what's so wild is that methane is a highly combustible gas. I mean, it's the exact same type of energy you find in natural gas and the CNG that lots of vehicles already use. So the real question is, how does soft food transform into such a powerful gas? To really get a sense of the scale here, just look at these numbers. In one Swedish city, Östersund, in just a single year, they collected 8,879 tons of food waste. And from all that waste, they produced almost 590,000 cubic meters of biomethane gas. That is enough fuel to run dozens of their city buses for an entire year. So that leads to the next crucial point. How does a country like Sweden manage to systematically collect such a massive amount of food waste to make this thing work all year round? Well, they have this highly structured strategy. They put out special organic waste bins, not just in homes, but everywhere. Restaurants, hotels, supermarkets, even food factories and wholesale markets. And here's the key. This waste is never mixed with regular trash. It's collected separately by special trucks and taken directly to a biogas plant. Okay, so once the waste gets to the plant, it begins its physical transformation. It has to be prepped for that secret process that's going to turn this mushy food into powerful fuel. It's a 3-step pretreatment. First up, sorting. Anything that's not organic, like plastic or metal that got in by mistake, is sorted out and removed. Second, the raw food waste goes through a giant shredder, which just chops it all up into small, manageable pieces. And finally, it's all mixed with water to create this thick liquid paste. They call it a slurry. And this slurry is what enters the heart of the whole operation, the invisible factory. This is where the real transformation starts, and it's all powered by those organisms we can't even see. So the slurry gets pumped into these massive, completely sealed tanks called digesters. Now the key here is that inside these tanks, there's absolutely no oxygen, none. And this creates the perfect environment for a natural process called anaerobic digestion. And this is where our invisible workers come in. Inside that oxygen-free tank, anaerobic bacteria get to work. These microorganisms, they thrive without oxygen, and they basically start to eat, or break down, all the organic particles in the slurry. And as they do this, they naturally release 2 gases, methane and carbon dioxide. But this creates a big problem. The gas that comes out at this stage isn't pure enough to be used in an engine. It's a big problem. The gas that comes out at this stage isn't pure enough to be used in an engine. It has to go through one more critical step to become a fuel that can actually work. You see, the gas from the digester is called raw biogas. It's got a lot of carbon dioxide, or CO2, in it, plus moisture and other corrosive stuff like hydrogen sulfide. If you tried to pump this stuff directly into an engine, it would cause some serious damage over time. So to fix this, the raw biogas is sent through a special upgrading system. First, the CO2 is scrubbed out. Then, other impurities are filtered away. After that, the gas is dehydrated to get rid of all the moisture. And what you're left with, the final product, is a high-purity engine-grade fuel called biomethane. And here it is. This is the crucial point that makes the entire system work. Biomethane is chemically almost identical to compressed natural gas, or CNG. The only real difference is where it comes from. Biomethane is renewable, while CNG, of course, is a fossil fuel. This chemical similarity is the key. It's what unlocks the final stage of this whole journey, turning this purified gas into actual movement on the road. Because biomethane and CNG are so much alike, the buses in Sweden that are already built with CNG-compatible engines can run on biomethane with no modifications whatsoever. The gas is compressed, it's stored in cylinders, and it's filled up at fueling stations just like regular CNG. When it burns in the engine, it releases energy, moves the pistons, and the bus just drives away. This whole process makes a very simple but powerful statement a reality. And the potential for this is just enormous. An average city generates thousands and thousands of tons of organic waste every single year. That's enough potential biomethane to power not just public buses, but also garbage trucks and even some private vehicle fleets. Our waste isn't just a problem anymore, it's a potential fuel reserve.